Hi everybody. Today I am going to talk about a print quality issue that I ran into, um, and I've seen others post on forums asking for advice. And every time I've seen images of it, I thought that can't be something's really wrong. I've never seen that. You know, it's such a high print quality printer that I thought either they had made some sort of terrible mistake, or there was something really wrong with that printer. But then I ran into it, and I'll tell you how I ran into it, how I corrected it, and what I think is probably happening or has happened to others to cause a similar issue. But when I had the issue, I was just throwing print files away, the prints away, and I corrected the issue, and I thought, I should probably share this to try to help some others out. So this isn't an actual print from a printer that actually has the issue. When it occurred, it was actually much worse. So very brittle prints, and clearly under extruding, extremely under extruding. I tried to use Simplify 3D to replicate the issue, and it was a little bit trickier than I thought it would be. So this is as close as I got, and I figured, if somebody saw this, they would say, "Oh yeah, I've had that issue," and this might be helpful to them. So the issue occurred after I was I wanted to see whether this open source setup could really go, how much material it could go through before I ran into any issues. I got through about 12 kilos of PLA. I would mix in 3D Systems OEM ABS every now and then when I needed it, and then I printed a complete spool of PETG. And when I switched back to PLA, that's when the issue occurred. And when I've seen pictures of this on forums, my advice was, "Oh, that's probably just a partial clog." Some people have said old filament. I don't think that would be the case. Old PLA is brittle, but if you can get it to feed without breaking, it'll print fine. I've never had a similar problem with old filament, so I don't think that could be the issue. So I gave people bad advice. The issue for me was that spool, that kilogram of PETG, had actually disintegrated the internal feed tube. I had maybe 4 or 5 millimeters. When I pulled it apart and pulled this out, there were only about 4 or 5 millimeters of tube, and the tube that was left here was clearly, worn away, disintegrated. The rest of it was inside and very fragile. I had to fish it out. Before I got to that point, I tried every trick I had for clearing, partial clogs, and they didn't work. So, if you run into this issue, my recommendation is pull the print head apart and check to make sure, this inner feed tube appears to be in good condition. I've made a couple of jigs that you can use. Now this one obviously is sized to cut both ends for this specific kit, but this should be useful for somebody with a similar open source kit, or even trying to make use of an OEM head. Maybe they just want to drive the ferrule back a little bit and recut. This should work fine. Also, I put a jig out on Thingiverse. I'll put links to these to reset the tube inside of the feed assembly. So in case you have to do those, these will help you with that. I recommend saving this. So if you're in the middle of converting to some sort of open source setup, you'll probably recognize this if you've ever pulled a cartridge apart. This is the guide tube inside of every cartridge. So the filament goes through the spool, and there's some little channels in the outer edges of the cartridge that this slides into, and it ultimately wraps around, and this part will slide up in under the feed assembly before it pumps it into the printer. Save this. If you're going through a conversion, you may think, oh, this is just trash. This is probably, for most people, this length of tube is probably a lifetime of new tubes, right? If this was completely destroyed, I could take this ferrule off, I could screw it onto here and cut it, and I'd have a brand new chunk of tube. One tool I highly recommend, this is probably my most used tool. I'm going to do a video with some open source recommendations. I'll get more into this. Is a 2mm rod. This is a 2mm stainless rod. I got a 10-pack of these shipped from Amazon for about $10. If you're into bikes or have a bike shop nearby, bicycle wheel spokes are also generally 2mm rods. You would just have to take it in. 2 of these is all you would need to do everything you need to do, and I'll get more into that in another video where I really get into open source. But so let's say you have this issue, you pull the print head apart, this all looks fine. The other issue I've seen, and I think could definitely cause this, is these ferrules, when they're installed on the tube, can kink the tube inside, and this 2mm rod is perfect for confirming that there's no kinks. What you will probably find is that if you tried to do this, you wouldn't be able to do it without a ton of force, and even then, I mean, you're probably on the verge of just ripping the tube. So you'll know if you run into that. I would recommend validating that this has no kink. This is the tube inside the feed assembly. That's where I most commonly have seen this issue. If you've messed with any end or both ends of the ferrule without using a rod inside, then very easily, very common to create a kink. So this is handy for that too. If I was going to fashion another chunk of tube and drive this ferrule up, I would absolutely have a rod in there. I have some soft jaws on my vise, and what I do is I slap it in there, and then I use this handy, 79-cent clip from Harbor Freight to quickly move that ferrule along and then recut. When you do cut any of these, right, you're going to want to use a razor blade square. Be careful. Make sure that the ends don't have any frays. Anything hanging on there that is frayed is very likely to end up in your print tip and ultimately cause a jam. So I hope that's helpful. I'm going to very quickly, for anybody that has this or a similar kit, I'm going to very quickly go through how to put one of these back together should you run into this issue. So if you don't have one of these and you're not interested, this is probably the time for you to check out. But I appreciate you hanging around for another one of my long-winded speeches. For the others, I'll show you very quickly how to put this together. The hardest part is at the beginning and really getting the spring into its seat and the print head into its seat. And I'm gonna have to wrestle with this one a little. There we go, got it. Make sure the ferrule sits where it needs to be. Obviously the tube has to go through this fitting here, and then what I do is I'll push on the print tip a little bit, finger on the back, and that holds it in place so that I can get this lined up. Sometimes this just snaps right together, and that's nice, but usually I've got to get a flathead in the mix just to just to get the spring to seat. So hard part's done. I know that looked easy. I've probably done this 100 times. That part can be a little frustrating. Take your time. It will come together. And once you've done it once successfully, it gets much easier. So once that is done, break out my handy 2mm rod. This is going to help ensure that I line up, everything lines up. The tube goes into the center of the push connect fitting, and it's a fairly snug fit. But once it's lined up, that's it. So I keep the rod in there until it's driven down. And now this is essentially a brand new print head ready to go. Feet assembly is a bit easier. There's an end that I like to put a chamfer on. That will go at the bottom. So I'll insert the hose into the push to connect fitting. I like to just spin the fitting until I feel it catch against the teeth of the thread, and then the top simply goes on square. Everything in this printer is machined to very tight tolerances, so this part in particular you may have wrestled with. If it isn't coming together easily, don't force it. You know, you'll hear it snap when it finally gives and goes in. If it's not coming together, you don't need to do that. Pull it off and then carefully put it back together and make sure it's nice and square, and it will go back on very easily. So I would simply add the bolts back to lock this up, and this is also brand new. If you run into an issue where you have a kink, I should have mentioned this at the front of the meeting, you can correct it with a 2mm drill bit. Now you're not going to put it in your drill and run it forward, you're going to run it in reverse. If you run it forward, you're going to remove way too much material, most likely destroy the tube. But if you run it backwards, it very gently, it will remove just a little bit of tube. The kink, whatever kink is causing your problem, will be removed. And then when you're done, make sure you drive through. This 2mm rod is perfect for making sure whatever is now in there gets pushed out. So there you go. I hope that's helpful. I've got a couple other ideas for videos that I'll post up soon. One talking about, you know, open source recommendations, things that I see people do that are definite no-nos, and you're not going to get much life out of, and some tools that I use. So I hope that's helpful. If you think of anything, you know, if you've got one of these and you can think of anything that isn't in my other videos, please post and I will do my best to help you out. Thank you very much.